Good afternoon, ladies and gentlemen. Today we're going to be talking about solving multi-step equations. Some of the steps we need to think about are, number one, simplify each side. Well, let's see if we can get the right size letters here. Simplify each side, if possible. Number two, distribute first. If there are parentheses, we have to distribute to get rid of them. So this is when necessary. And number three, our goal is always to isolate the variable. We will do this by following PEMDAS backwards. And remember to always check your answers. That's the nice thing about solving equations, is that you can check your answers. Now, there are different kinds of solutions that we're going to be getting. This is something new. Most of the time we will get one real solution. But there are going to be times when the variables disappear and we will get no solution. The symbol we use is a circle with a line through it. There are going to be other times that the variables disappear and we get a true statement, and then the answer will be all real numbers. The symbol for that is this R looking thing. And I'll tell you a little bit more about that as we go along. All right, let's do a little practice here. Let's say our equation is 33 plus x plus 2 equals negative 5 plus 2x minus 6x. All right, so as we said, we want to combine like terms on a side first. That is, simplify each side. So I get out my colored pencils and I circle the positive 2x and the negative 6x. They add up to negative 4x. I bring down the negative 5. I bring down the equal sign. And I use my colored pencil to show that 33 and positive 2 can add together. They add up to 35. I bring down the plus x. And now I have to decide which side of the equation I want to collect my variables on. I prefer to have a positive number in front of my variables. So I'm going to add 4x to both sides. Remember, you always have to do your process to both sides. These will cancel out, and I will get negative 5 equals 5x and 35 on this side. If I subtract 35 from both sides, I'm running over that you try word, so don't worry. I get 5x equals negative 40. Divide both sides by 5, and I get x equals negative 8. All right, so here is your you try. Number 1 is 11w minus 9 minus 7w equals 15. You try number 2, 23 equals negative 4m plus 2 plus m. All right, what happens when we have the distributive property? Because there are parentheses. Let's see. If our problem is 5h plus 2 times parentheses 11 minus h equals negative 5, the first thing I want to do is distribute to get rid of those parentheses. I'm distributing positive 2. 2 times 11 is 22. 2 times negative h is negative 2h. I bring down the equals negative 5, bring down the 5h, and again I have to combine like terms on a side. Whoops, there's a plus sign missing there. I'm going to add 5h and negative 2h, which gives me 3h plus 22 equals negative 5, and now I have a two-step equation. I'll subtract 22 from both sides, and I'll get 3h equals negative 27. Divide both sides by 3, and h is equal to -9. Okay, here's another example with the distributive property. If I have -12y minus 3 equals -5 times 2y minus 7, what am I distributing this time? This time I'm distributing -5. -5 times 2y is -10y. -5 times -7 is +35. I bring down the equal sign and everything else I haven't touched yet. Once again, I have to decide which side of the equation I want to collect the variables on. So I'm going to add 12y to both sides because I prefer to have a positive number in front of my variable. I can also subtract 35 from both sides, and I get -38 equals 2y. After dividing both sides by 2, I will get y equals -19. Here's your u trie. 14 plus 2 times 4g minus 3 equals 40. And here's u trie number 4. -3c plus 27 equals -3 times 6 minus 2c. All right. What if we have a fraction in front of our parentheses, like 1/3 times d plus 3 equals 5? Do I want to distribute that fraction into that parentheses? I do not. So I'm going to multiply both sides by 3, that number that's in the denominator. Because the fraction is just being multiplied by the parentheses, and that's the whole side, the 3's will cancel out, and I'll be left with d plus 3 is equal to 5 times 3 is 15. And when I subtract 3 from both sides, I'll get d is equal to 12. What if I've got a different kind of fraction? -14 equals 2 over 5 times 9 minus 2b. I'm going to use the same technique. I'm going to multiply both sides by, what's the denominator this time? It is 5. I'm going to multiply both sides by 5 because I want those 5's to cancel out. That denominator is what's giving me a headache. And I get 2 times 9 minus 2b. And on the other side, 5 times -14 is -70. Now I distribute to get rid of the parentheses. 2 times 9 is 18. 2 times -2b is -4b. And now I've got my two-step equation. Subtract 18 from both sides, and I get -4b. Make sure you bring that minus sign with that 4b. It belongs to that 4b. And when I divide both sides by -4, I will get b equals 22. Here's u trie number 5. 4 equals 2 over 9 times 4y minus 2. And we need u trie number 6. Here's u trie number 6. 12 equals 4 over 3 times 7 minus n. All right, now I told you that there was going to be something new here. We got special cases. That is when the variables disappear. What if we start off with 8z equals 4 times 2z plus 1? When we distribute to get rid of these parentheses, we get 8z equals 4 times 2z is 8z, and 4 times +1 is 4. Uh-oh, that doesn't look good. And if I subtract 8z from both sides, I will get 0 equals 4. False. If the variables disappear and you get a false statement, your answer is no solution. Let's look at another example. 2 times 3g plus 2 equals 1/2 times 12g plus 8. This time I am going to distribute because I know half of 12 is 6, so I get 6g here, and half of 8 is 4, so I get positive 4 here. And if I distribute on this side, 2 times 3g is 6g, and 2 times 2 is 4. Look at that. They look like they're the same on both sides. And if I subtract 6g from both sides, I will get 4 equals 4. True. If the variables disappear and you get a true statement, your answer is all real numbers. That sign means numbers, not hashtag. All right, here's your U try. 12 plus 6 equals 6 times 2y plus 1. And I've got one more U try for you. U try number 8. 2 minus 15n equals 5 times negative 3n plus 2. Track your additional notes and questions, and we'll see you in class.